This video is about simplifying and evaluating variable expressions, and it's lesson 16 in your book. When we evaluate expressions with variables and we have a given value for the variable, all we have to do is plug that given value in everywhere we see the variable. So in our first example here, and yes, you need to write both of these down in your notes, we have negative a times p minus a, for a equals 3 and p equals 4. Now all we have to do here is plug 3 in everywhere in this expression we see an a, and plug 4 in everywhere in this expression we see a p. When we do that, it's going to look like this. We're going to have negative, and then instead of a, we'll write 3, times, write our brackets, negative, again, a is 3, times p, which we know to be 4, minus a, which again is 3. Once we've plugged in the numbers for the given values of the variables, all we have to do is use the order of operations to simplify. So we'll start with parentheses, and we always do the grouping symbols the furthest inside. So these parentheses are inside the bracket, so I'm going to do 4 minus 3 first. I still have my negative 3 on the outside, my bracket, negative 3 times, and 4 minus 3 is 1. Now that I'm done with my innermost parentheses, I work inside the brackets. I've got negative 3 times 1, so I still have my negative 3 on the outside, and then negative 3 times 1 is negative 3. And when I multiply, negative times a negative gives me a positive. 3 times 3 is 9. Again, all I did there was plug 3 in for a and 4 in for p and follow the order of operations. I'm going to do the same thing with the second example. I know a is negative 2 and x is 7. So everywhere I see an a in this expression, I'm going to plug in negative 2. And everywhere I see an x, I'm going to plug in 7. So I can rewrite it as negative, and then x is 7, plus a, which is negative 2, minus x, which is 7, minus a, which is negative 2. Then I'll follow my order of operations to simplify. So I work inside parentheses first. I've got negative 7 plus negative 2. Now I know these are both negative, so the answer I get will be negative, and 7 plus 2 is 9. Then I've got minus. Now here I have 7 minus negative 2, and I know that subtracting a negative is the same thing as adding. So it's really 7 plus 2, which is positive 9. Finally, I subtract negative 9 minus 9 gives me a negative 18. So the solution for this expression is negative 18. Now those were expressions with 2 variables, and now we have expressions with 3 variables. You do them exactly the same way, except that you have more numbers to plug in. These are examples. Again, they need to go in your notes. Here I have yx times zyx for x equals 2, y equals negative 1, and z equals 4. So everywhere I see an x, I'm going to plug in 2. Everywhere I see a y, I'll plug in negative 1. And everywhere I see a z, I'll plug in 4. Y is negative 1, so I have negative 1 times, when they're written next to each other, that means we're multiplying, x, which is 2, times z, which is 4, times y, which is negative 1, times x, which is 2. Now I work inside my parentheses, so negative 1 times 2 in the first set of parentheses gives me negative 2. In the second set of parentheses, I go left to right. 4 times negative 1 is negative 4. And negative 4 times 2 is negative 8. Finally, I multiply my two quantities. Negative 2 times negative 8, that's a negative times a negative, so it'll be positive 2 times 8 is 16. Alright, same thing again for this next example. X times 4AP all over XP. A equals 1, P equals 5, and X equals negative 3. So I'm going to plug in 1 everywhere I see an A, 5 everywhere there's a p, and negative 3 everywhere there's an x. So I have x, which is negative 3, times 4, times a, which is 1, times p, which is 5, all over x, which is negative 3, times p, which is 5. Alright, now this fraction bar, again, is a symbol of inclusion. So that means I have to work everything above the fraction bar and everything below the fraction bar before I can divide those two. So on the top, I've got negative 3, bring my work over here, times, and in the parentheses I have 4 times 1, which is 4, times 5, which is 20. And then in the bottom of the fraction bar, I have negative 3 times a positive 5. Negative times a positive gives me a negative, and 3 times 5 is 15. Now negative 3 times 20 gives me negative 60, and I'm dividing that by negative 15. And finally, a negative divided by a negative is a positive, and 60 divided by 15 is 4. So our solution to this expression is 4. Sometimes we can simplify before we evaluate the expression, and that's what I'm going to do in these two examples. You do need to write these down as notes in your notebook. See here how we have the negative x times, in parentheses, y minus 3. I can use the distributive property to distribute this negative x before I evaluate this expression. So if I multiply negative x times y, I get negative xy. And then I also have to multiply negative x times 3. Negative x times 3 is negative 3x. And I put a minus in between them because that's my sign right here. And then I've got plus y on the end. Now if we want to simplify this a little further, we can say it's negative xy, and then instead of minus the negative 3x, we can say plus 3x plus y. Now this is a little simpler, and now I'm going to plug in the values of my variables. So x is 0.5 and y is negative 1.75. So if I plug this in here, I get negative, and x is 0.5, times y, which is negative 1.75, plus 3 times x, which is 0.5, plus y, which is negative 1.75. Now when I do my multiplication, I do negative times 0.5, which is negative 0.5, times negative 1.75. Now that's a negative times a negative, so I'm going to have a positive, and 0.5 times 1.75 is 0.875. Here I've got 3 times 0.5, and when I multiply those two, I get a positive 1.5. And here I have plus a negative 1.75, so I'm going to rewrite that as minus 1.75. Now when I do my addition and subtraction, left to right, and I take 0.875 plus 1.5 minus 1.75, I get 0.625. Alright, now let's go to the next one. At first I'm going to simplify, and then I'm going to evaluate the expression. So I'm going to distribute this x by multiplying it by each term inside my parentheses. So here I have x times x, and when I rewrite x times x, I'm going to write it as x squared. Then I've got a plus in between them, and then I've got x times 2y, which gives me 2xy minus x. Now I'm going to plug in 1/2 everywhere I see an x, and 1/4 everywhere I see a y. So this gives me 1/2 squared plus 2 times x is 1/2 times y, which is 1/4, minus x, which is 1/2. Now I need to do exponents first, so 1/2 times 1/2 gives me 1/4. Be careful, 1/2 times 1/2 is 1/4, not 1, because 1 times 1 is 1, 2 times 2 is 4. Next, I'll do my multiplication, so I have 2 times 1/2. My 2's cancel here, and I'm just left with 1. And 1 times 1/4 is 1/4. And then I have my minus 1/2 on the end there. Now when I add and subtract left to right, I have 1/4 plus 1/4, which is 1/2, minus 1/2. And when I subtract 1/2 from 1/2, my answer is 0. Alright, now let's look at some expressions with exponents. Again, these are examples. They do need to be in your notes. We have, if m equals -2 and y equals 2.5, what is the value of ym cubed? I want to take this expression and plug these numbers in for m and y. So I rewrite it as, instead of y, 2.5, and instead of m, -2, and then I've got my cube up here. Now this cube, this third power, only applies to the -2. It does not apply to the 2.5, and I must do exponents before multiplication. So this is the same as writing 2.5 times, and if I'm cubing something, I'm multiplying it 3 times, so times -2 times -2 times -2. Now, when I multiply this across, I have -2.5 times -2, which gives me -5. Then I have -5 times -2, which is a positive 10. And finally, I have 10 times -2, which is -20. Be very careful that you only apply the exponent to the base that it's designated for and not to the whole quantity. And finally, here we have, if a equals 3 and b equals -1, what is the value of 2 times a over 5 minus b squared? Now I'm going to plug 3 in for a and -1 in for b, and then follow my order of operations to simplify. So I have 2 times, in parentheses, a, which is 3, over 5 minus b, which is -1, and that whole thing is squared. Now before I can apply this exponent, I have to work inside my parentheses. I still have the 2 on the outside, the 3 on the top here, and 5 minus -1 is the same as 5 plus 1, so it's 6, and I'm squaring that. Now I know that I can simplify 3/6 into 1/2, so I'm going to do that next. Now I have 2 times 1/2 squared. That's the same as saying 2 times 1/2 times 1/2, because I'm squaring the 1/2 or multiplying it by itself. Now here, 2 times 1/2, this is like 2 over 1 times 1/2. My 2's cancel, and I'm just left with 1. 1 times 1/2 is 1/2. Alright, and we do have time for this one last example. Please write this in your notebooks as part of your notes. If a equals 3, what is the value of the absolute value of -a to the third? So I want to plug 3 in for a, so I'm looking for the absolute value of -3 to the third power. Now that means I have the absolute value of -3 times -3 times -3. Now those absolute value bars do not make everything inside here positive. They simply make the result of everything inside positive. So I have the absolute value of -3 times -3 is a positive 9 times -3. Or the absolute value of 9 times -3, which is -27. And I know the distance of -27 from 0 on the number line is a positive 27. And that is my solution.